start off. So beta elimination reaction, a reaction in which, okay, whatever, this part is fine. Now, this is very wrong. Never write your reaction like this. Your synopsis absolutely should not be this. This is wrong. And in this particular case here, what does this basically mean here? What is it supposed to be?
So when the solvent is weak base, then
Okay. Weak base.
like,
Okay.
oh, you don't understand.
I understand what that meant. Weak
Oh
base.
yeah, I got it. Yeah.
So he has discussed E1 here basically, right?
Yeah.
Okay, I'm not doing this fellow's discussion of E1. Okay. So let's start off. So if I'm going to be having elimination first order, what does elimination first order really mean? What is it really competing with? So first of all, when you want to understand the elimination reactions here, the key thing which you need to pick up on here is this. You are having many parts in a reaction. All right. So what do I mean by many parts in a reaction? Let's say I'm having the same substance which you guys have taken. Okay, this was the compound which has been taken over here. Correct. So this compound here, if I'm going to be considering it. Now, a better system to consider and start learning elimination is this guy. So I'll be starting from here. I'm not going to be starting from the chlorine one. The chlorine one will come to when we come to it, because this is a better example to understand the game here. So what I'm going to be using is, I'm going to be actually using concentrated sulfuric acid. You have done this mechanism, yes?
Yes.
So what is the mech for this guy?
Give me a second.
So
it dissociates into ions first.
Which
H
one
plus
dissociates
plus
into ions first?
the concentrated H2SO4 or H3PO4. Then that H plus will come and attack the OH minus. The OH.
Good. So you
Positive
have
charge
good
will
clarity
here.
as to what's happening here. So explain step by step here as you're continuing. H plus comes and attacks here.
H
What
plus
happens
comes
next?
and bonds with OH. Then you get a OH2 plus.
OH2 plus. Okay.
Then we remove. Wait 1 second. We remove the water molecule.
Good. We remove the water molecule. So the water molecule takes the 2 electrons present here and gets out. Okay.
So it takes the 2 electrons because it's more electronegative, right?
Yes, exactly. The oxygen here is something which is having a positive charge, and it is of course far more electronegative. Whenever you are looking at electronegativity is the property which basically describes control of a particular atom in a bond over the bonded pair of electrons. So the more electronegative atom is always going to be the one which is going to be controlling the 2 electrons present in a bond pair. So yes, because the oxygen is more electronegative over here, it takes the 2 electrons and it gets out. So what will it become?
Carbocation is formed.
Carbocation is formed. Okay. And now is when things get interesting.
The negative part.
Okay. So here is where your teacher has not really given you proper information. So here, what is the pathways available right now?
The SO4, HSO3 minus could come and attack.
Okay. So he has discussed
Or
other possibilities then as well to an extent. Okay. So HSO3 minus can come and attack. Then what else can happen?
mm, there is no watchman.
Hmm. What else can happen? So the complication which happens here is mainly because of the fact that your teacher was very smart to take a case which basically does not ask so many questions. Mainly because most of the other possibilities get shut down the moment you take this big guy. This is a very bulky fellow. It is going to be only offering only one pathway as a possibility. Organic chemistry is something which is goddamn like real life. It is real life. So there is never going to be one possibility ever. But in this case, you don't see more than that one possibility predominantly. So let's take the same thing with a slightly different example. I'm going to be considering ethanol now.
Mhm.
If the same thing happens here, first we'll effectively end up having H plus produced, which will go attack this guy. This will end up becoming an OH2 plus 1, which then ends up kicking this guy out to release a carbocation, which is pretty much where we are. There were some paths available for us. First was we basically said HSO3 minus can come and do business over here, or we can have this guy getting out, this guy can shift over here. That will be our E1 pathway, right?
Hmm.
What
Sir,
else?
when all does this like an atom is leave the group? Like when does that happen?
We'll talk. In this
Right.
case, this has happened.
Oh,
Okay.
when's it conjugation
Sorry?
or something? Okay, okay.
You're asking what exactly? Be more specific. Are you talking about the OH leaving or the hydrogen leaving?
Hydrogen leaving.
So, this guy is your pain center now,
Yes.
correct? So, this carbon is going to be something which is going to be extremely electron deficient right now. It wants to reach octet however possible.
Hmm.
So, on this other carbon atom here, what is going to be happening is this carbon is now positively charged. Now, it doesn't have octet.
Hmm.
So, when there is no octet, what happens to the size of that system?
It's decreases.
Decreases dramatically
Hmm.
here, correct?
Yeah.
It's far smaller in size. So the electronegativity of the atom is now
Greater. Yeah.
far higher than what it used to be. So when it is far higher than what it used to be, what will simply happen here is this carbon atom, this fellow which is having a positive charge, will now literally do the same thing. You guys learnt about rearrangement of carbocations.
Hmm.
Why does it happen?
Stability.
Why does it happen? Only on those ones specifically. And why specifically in that order?
In which order?
You learnt about some rearrangement. I mean, when the rearrangement is happening, this guy is better than that guy is better than this guy, and shit, na? A priority order you would have been given.
I don't remember. I
Knowing
don't
your
think we
teacher
learned.
and the kind of stuff he's taught you, I'm quite sure he would have given you a priority order for rearrangement.
No, we didn't. Oh, oh, yeah, yeah, yeah.
Yes,
Wait, I don't think this is. I don't think we had it. Hydrate shift only, right?
hydrate shift is going to be better than methyl shift, obviously.
Huh.
He has not given you a full-fledged priority order there at that season.
Yeah, no.
I don't know what is going through this fellow's mind. He teaches like some shit at like ridiculous depth, some basic shit which are supposed to be given, he doesn't give. Okay, so yeah, hydride shift is better than methyl shift alone. You have learned so far. Then
Yeah.
okay, so let's quickly talk about why the shift happens. The shift happens based on the same reasons which I'm talking about here. This carbocation is something which is now far more electronegative. So it literally is like this. Let me show it to you straight away. This will be easier. So let's say I'm considering this as the molecule here. Let's say this is the carbon atom which is screwed over. All right. So if it's a carbon atom which gets screwed over, let me put it like this. Some planar phenomenon. Okay. So this carbon atom here becomes a carbocation. It's a planar fellow. So what happens here is this fellow has got 3 groups on it. So this carbon is now far, far, far more electronegative. Being far more electronegative, it doesn't care what it is targeting here. This carbon atom here will target any one bonded pair of electrons here. When I say target, think of it like this. This carbon is bonded to this. This is highly electronegative. This fucker is satisfied. All right. So this guy is jealous literally for the electrons present in these 3 bonds here. Literally. So effectively speaking, bluntly apply KQ1 Q2 by R squared. Whichever is going to be having more electron density present here and is closer to this will be pulled away by it.
So if there is a double bond there, then that pi bond would go away.
No, there will be no pi bond. The pi bond, fair enough, fair enough. If you're having a pi bond away, pi bond.
Yeah, that's what I mean.
Yes, absolutely. Why? Because pi bond is weakly
more electronegative.
It is not that more electron density over here. So that will basically directly shift over there. That's the idea. Yeah. So literally speaking, this desperate creature will pull whatever is closest to it, whatever is maximum for it.
Sir, if it was deficient enough, would it take more than 1 bond?
No, it will never take more than 1 bond. Because the moment, remember, think for a second, if this is going there, remember everything is real time. As and when this guy is getting satiated, it will lose its electronegativity.
Oh, but then what if it had +2? And then
there will be never a +2. Don't make up theoretical bullshit which you are not going to be ever getting. There is enough complication in the world already with organic chemistry. Don't make up more unnecessary shit. Don't allow your brain to come up with your physics shit here. Okay, this has got enough complications as is. In this here, the basic idea here is this extremely jealous, highly electronegative thing will effectively literally pull these electron densities in any one of the bonds. The simple factor will be pure KQ1 Q2 by R square. You're familiar with what KQ1 Q2 by R square is supposed to be?
Yes, sir.
Pure electrostatics. So this pure electrostatics here will basically look at what factors, which factor will be most important in the factor over there. If I'm considering R. Beautiful. So now you understand why hydrogen goes.
Sir?
Why is hydrogen? I'll give you the priority order for the shifting here. That is, in this shifting here, there is going to be a priority order associated with it. The priority order will basically be hydrogen.
Like leaving group.
Don't call it leaving group. You're using some unnecessarily dangerous words here. Leaving group is something very important in organic chemistry. Literally, that's what I'm about to discuss right now.
Oh.
So don't call this one as leaving group. That is very, very dangerous. So priority order for shifting, let me quickly give it here. So effectively, you'll end up having hydrogen or hydride shift being the best. Then you will end up having any benzene ring with a plus R, then a plain benzene ring, then a benzene ring with a minus R. Then you will end up having a tertiary carbon. Then you'll have secondary carbon. Then you'll have primary carbon. And then you'll have methyl. Methyl is one of the worst things to shift. Now, why is it in this here like this? The reason is mainly because of what I just explained here. When you're going to be having this carbon here pulling a bond over here, it is purely dependent on KQ1 Q2 by R square. Now, when it comes to the Q1 and Q2, this bond over here or this bond here or this bond here, whichever bond has maximum electron density will have maximum Q. Which means it will have maximum attraction by this guy, which means it will pull it. That part explains your why benzene ring with plus R is going to be the best. Because if there is a benzene ring with plus R connected here, it will be feeding electron density here. That means this bond will be very highly electron rich here.
Will be, yes.
So think of it like this. This guy is a pickpocket. All right, who is going to go, who is, or not even a pickpocket. All right, let's say you say you are, this is going to be very nasty, but it's a real example which can happen. So it's worth it to discuss. Let's say you've graduated out of college, you're jobless, but you're a bad character. Nobody's there around you, right? Nobody's around you, yes?
Yeah.
But you have got bad character. All right, you're still staying at your parents. You have bad habits. What will you do? You'll start lifting from your house.
Yeah.
Possibility will creep into your mind.
Yeah.
And when you're doing that, you'll take the lowest hanging fruit, correct?
Yeah.
You will not try going after unnecessarily risky stuff. But
Yeah.
you'll take whatever you can take easily, but high value. Because you don't want to do multiple times. That increases the probability of getting caught.
Yeah.
Pretty much exactly what this guy does. Right?
Okay.
That is pretty much exactly what this guy will do here. So this fellow here will basically be attracted to one of these here. Whichever is most efficient. Why is this the lowest hanging fruit? Because it is closest to it. If there's a large molecule connected here throughout, this is the lowest hanging fruit, right?
Yeah.
So this is your mom or dad's wallet. This is that
Yeah.
tray in the house where there will be a little bit of cash usually kept.
Yeah.
So the lowest hanging fruit is this. So in that lowest hanging fruit, it will pluck the one which is going to be most ideal for it. High value targets, basically. Because it can't go do this many times.
Yeah.
It'll pull whatever is easiest for it to pull, whatever it is most attracted towards. So the attraction depends on the amount of electron density, certainly. But the attraction also depends on how easy it is for this
Approachability.
to manage it. For instance, let us say there is $100 bill in your house, US dollar bill, randomly kept for Vastu. Can that be lifted?
Yeah.
That cannot be lifted that easily. Because even if you lift it, converting that is going to be a pain in the ass later.
Yeah.
So, coming back to where I was. So the idea here is when you're going to be having a system like this available here, the group which is going to be migrating is going to be density here, but it also depends on R value. Because if the R is smaller, the entire game is changed. Because it's KQ and Q2 by R squared. So this guy's attraction is definitely more attracted to the R part there compared to the Q. The R part will not matter when there are carbon-carbon bonds. If it's carbon-carbon bond over here, almost always it is going to be only single bond we are talking about here.
Yes.
Single bond is going to be approximately similar lengths only, not that much difference. That means this carbon, which is in the back fellow here, will be like approximately similar distance from this carbon here.
Yeah.
And it will be similar distance from this bond.
Yes. You can attack any of the one.
Exactly. All three of them are going to be relatively equal with respect
equally
to
probably.
So in that case, when it is carbons, the bond electron density factor starts mattering more.
They're also fairly be equal, right?
Yes, that is unfortunately going to be true. But the reality is, this is something which is going to be present closer to this carbon. Correct?
Oh.
Think the bond is what it is attracted to now. That's what it is taking. Bond is a pair of electrons. That is what this guy is attracted.
Yes.
So even if the distance is going to be similar now it doesn't, now it is not about the distance factor truly, but it is definitely going to be having similarities with respect to the amount of electron density, but that is what is going to be more attractive now. Because that is what this guy is going after literally. So in this particular case here, you are going to be having similarities, yes, but there are differences which get magnified at this stage now. So when you're going to be having carbons present over there, the amount of electron density in that bond will start mattering a lot more, and that is what your priority order is based on. That is the priority order here, which talks about this part. That is going to be based on that. Same as this part over here. This entire part here is based on the fact that whichever is going to be having more electron density in that particular bond, that is going to be the one which is going to be more strongly attracted by this particular sp2 carbon, which will pull it up. Hydrogen, on the other hand, is purely based on R. Because if it is a carbon hydrogen over here, if it's a hydrogen here, what happens? The hydrogen is extremely tiny.
Yes.
That means this bond, which was carbon-carbon originally like this, is now becoming like this.
Yes.
Which means this guy is now far closer to this bugger.
Yes.
Think of the distance there directly. It's far closer. That wins, hands down. No questions asked.
Okay.
You understand the idea there? There
Yes,
are
sir.
other factors also applicable, obviously, which are going to be involving how much repulsion this carbon over there or that guy is going to. All of those matter. I'm not saying those don't matter, but the truth is, those are going to be there everywhere.
Yeah.
So when you're going to be having those factors, and they are at greater distances as well, much greater distances compared to the electron density in the bond over there. That's why they don't really matter so much. So this is going to be the general rearrangement thingy or rearrangement order for everything. Now,
sir, what if there were two cations attached? Like there's a carbon here, and between there's a normal carbon which is satisfied octet.
Let me ask you a question here. What is the chance of that surviving and you observing it?
Yeah, pretty much 0.
Exactly right.
Yeah.
Then is there ever a chance of that being something which can be studied in detail, even if it exists?
Okay.
You understand where I'm going with your point?
What if there's a plus and a minus?
Think again.
Right.
Think again. Same logic applies. Whether it is a plus or a minus, it is a bullet wound, bro. Think of it like this. How many times do you see a John Wick in real life? Fucking never, right?
Yeah.
Why? Because nobody can survive that many kind of bullet wounds and shit and whatnot. We get shot once, we'll fucking move the fuck away. We'll make sure we protect ourselves like crazy. Right?
Yeah.
That's exactly what happens to atoms and molecules as well. So when you're going to be having an atom or a molecule or a system which is going to be having a charge, any charge, every charged location which is present is a bullet wound for that particular system. It makes it highly unstable. So when it makes it highly unstable, it will, even if there is a possibility of it having a plus and a minus, it will be on different ends of the molecule, different parts or different corners of the molecule, and it will definitely not be on goddamn carbons. It will be on things which can handle the charge in a better manner. Like say nitrogen with an octet and having a positive charge, ammonium type on one end, and an oxygen with a negative charge on another end. You remember what we talked about in ionic equilibrium? Zwitter ions.
Yes.
That is exactly what you're talking about here. That is the only type.
3 plus.
Yes.
Nothing.
You're saying something now?
No, nothing.
So effectively, those are the only kind of species which actually can manage to maintain two charges opposite simultaneously and stay stable enough to be observed properly by us.
So this shifting only happens for adjacent carbon, right? Or could it happen? I don't think.
Think for a second. Did I
adjacent
tell you anything about what did I explain just now? Did I discuss any conditionalities in chemistry? No. Right? I just discussed the physics of it. Now you use your brain and apply the physics of it with chemistry. Tell me, when will that possibility happen? What did you ask? Ask that same question again.
1 second. So I said, if a carbocation is like 2 carbons away from, no, I don't think it would happen. No.
Can it?
No.
What is it dependent on?
Distance.
Kq1 Q2 by R, Kq1 Q2 by R squared. So use your brain. If
Okay.
there is a pipeline available, it can do it. But a pipeline has to be available. And that
What do you
pipeline
mean?
has to be in the first location itself. It has to start at this location itself.
Pipeline
If it
meaning like
doesn't start
double.
at this case, wherever we talked about that rearrangement location, it cannot do it. Because electronegativity is a pure distance factor. When you become that desperate, if you become that desperate, you cannot steal from me. You cannot steal from your grandparents so much. You can from your parents. You understand what I'm saying?
Yeah.
But if it is going to be something, if your question, can you technically live from your grandparents? Yes. If it is a passed down item, that can be lifted.
Yeah.
You understand what I mean by a passed down item?
Yes, sir. Yeah.
That is going to be similar to your resonance over here. When there is conjugation extended,
Oh, okay, I
lift
see.
from that direction.
Oh, like a okay.
So what do I mean here? Let's say I'm going to be having a carbocation here. Okay. So this carbon is going to be having some bonds over here, correct? So now if the bonds present here, let's say they are like single bonds only, then this will happen. Let's take a double bond on one side. If I have a double bond, what is going to be happening? Which is the lowest hanging fruit now? Exactly. Pi is the lowest hanging fruit. So that pi cloud will directly get pulled here.
Yes.
So if there is a connection for this fellow with another tank of electron density.
So that'll also get pulled.
Exactly.
Oh, I see. Okay. Could you connect that carbon like that? Okay.
Yes. Basically, this fellow's desperation pulls from here, right? Now who becomes
Which
more
causes
desperate?
his
This
desperation.
guy becomes more desperate.
And that guy pulls that.
This guy pulls it.
Okay.
You understand?
That's when it was conjugation.
That is what I was talking about. If you understand the goddamn KQ and Q2 by R squared properly, you don't need to understand anything else.
Okay. Yeah. I understand.
You understand what I'm trying to explain here?
Yes,
Exceptions come into the picture only when your physics is not ingrained. When you link up your chemistry with the physics part bluntly, there are no exceptions. If there are still exceptions, those are very complicated. And you don't need to really give a shit beyond a point here. See, what is the highest stage which a JEE student can reach ideally? Link up all three subjects internally.
Oh, okay.
That is the highest stage a true JEE student, a real top ranker will be reaching. When I say link up, I really mean connect it. Understand the intricate connections here. You can see how there is enough connections in every place. All you have to do is open your eyes to look at it. But they are not easy to look at. It's not like what to say, others do not see these. It is just that they refuse to look at it. Because it gets very painful to see beyond a point. So in this particular case here, conjugation is literally that only. In conjugation, what is happening here is this guy's desperation makes this guy more desperate, which in turn basically ends up doing the same thing the first guy did, which is attack the lowest hanging fruit. Everywhere, that's the basic principle. KQ1, Q2 by R squared will be followed. Because that's goddamn physics. Physics is not going to be lying to you. So, but at the same time, remember, there are other systems also at play here. You are going to be having other electron densities also present, like nucleuses. Nuclear repulsions also need to be considered. Steric hindrance is predominantly going to be of that factor only. Now, coming back to the elimination bit there, which we were talking about, let's come back to this one. So, HSO3 minus is one pathway, E1 pathway is one. What are the other pathways available? What else can happen? What is this system?
Electron deficient.
Carbocation, electron deficient. So it is an electrophile, obviously.
Electrophile, yes.
And it is attracted to what?
Nucleus. I mean, positive charge.
Attracts electron-rich species, not positive charge.
Oh, sorry, negative charge. Sorry. Yeah.
So it attracts electron-rich species. So if this guy is going to be attracting electron-rich species here, that's why you got your HSO3 minus.
Yes.
That is why we had this pathway, which is pretty much the same thing of what to say rearrangement,
Attracting the bond pair.
which is what we've been discussing all along. So I'm not going to touch
Yes,
this
yes,
pathway for now. Let's talk about the third possibility. What else is electron rich? What do I have in the mixture now?
Sir, another molecule of this thing.
Tell me.
Is ethanol.
Wonderful. Good. Not bad. So I will have a molecule of ethanol as well. So you are going to be having this bugger also having
Yes.
electron density.
Yeah.
So the problem, the real key problem here is not the HSO3 minus, it is this bugger.
Oh.